Hello, hello. Oh, Jonah, yeah, okay. Can you hear me?
Yes.
Okay, can. All right, we'll start at two sharp. Okay, today we are going through. You received the materials, right? So we are going to go through trigonometry and coordinate geometry. Okay. Yeah, you can take a look at the topics and let me know if you have any concerns about any of these in particular.
Trigo.
Okay, you can take a look through and see if you think we covered. Um, okay, anything in particular that you want to focus on? Okay, and there might be some content in Trigo that might be excluded for you. You later you can maybe let me know. Cause okay, for Trigo, okay, I think for only for differentiation of like you do not learn differentiation integration of Trigo stuff, right? I don't think so. Okay, yeah, that one I think like for normal Trigo looks like you have everything. Okay, then like if I go through anything then like some stuff that like you haven't heard of before, then yeah, just let me know. Okay, but yeah, I believe everything should be included. The next air lesson, I think I'll be coming. Oh, okay. Yeah, we can be recorded. Yeah. Okay. Okay. Then we can begin. Alright. So yes. Okay. So today there's not many topics. It's just two. Okay, but it's pretty long. Trigo usually is the topic that people like struggle with the most in AMath. Okay. All right. Okay. Then can you see the screen? I started sharing.
Yes.
Okay. Good. All right, so let's begin our discussion on. Okay, I will let's start with module three. Okay, so module three, all right, we'll be talking about trigonometry and coordinate geometry. Okay, so it's just two topics, right? I think we can probably. Okay, yeah, I think we can definitely finish before 3 hours. Okay, so I think for this lesson we can focus some on some questions as well, maybe some O level questions. So to get a general gauge of how the question might look like in the exams. Okay. Because obviously these are mostly just concepts, right? They're not the hard questions. Okay, so yeah, trigonometry is very long. It's one of the hardest chapters. A lot of people say it's hardest chapter. Then coordinate geometry, personally, I don't think it's that bad. Okay, once you can manage to visualize and then know what to calculate, I don't think it's that bad. Okay, it's just troublesome. Okay, so let's start with trigo. Okay, so there are many objectives. I don't think I'll go through each of them one by one. Right. Okay, main points: the use of each of the trigo functions, and then calculate exact values, and then sketching graphs, taking note of amplitude, periodicity, and symmetries. Then using trigo identities and formulas. How to simplify trigo expressions, solve trigo equations, prove trigo identities, use trigo functions to model real life situations, and calculate these things called the principal values of inverse trigo functions. Okay. So definitely a lot to cover for this topic. Okay. I think, yeah, since we do have some I mean we do have 3 hours. Maybe if we cover like each section, I could let you guys try like apart from the questions that are already here, maybe we can try some of these O-level questions. Okay. So yeah, the previous session I did now, right? We did have some time to try some of these questions. So and we can try it together to see like harder questions in like after each section of the topics. Okay. Okay, so first we begin. Okay, so we talk about the radian first. Okay, the radian is the first the concept. I think in AMath, I think they kind of introduced it. Okay, that's a refresher. Okay, AMath they kind of introduced it, but I think they don't really use it like too much. Like very rarely in some circle questions. Okay. So what is a radian? So a radian is a unit of measurement, which is the angle subtended by the center of the circle by arc equal in length to the radius. Okay. So of course that's a pretty complex definition. Okay. But if you look at the diagram, okay, the arc length is this and then the radius is this. So whatever if the arc length is equal to radius, then this angle here is 1 radian. Okay. Then you can derive that S equals to R theta, okay, where arc length basically equals to R times the angle subtended. Okay. This arc length here equals to R times this. Okay. Then it tells you that theta equals to S over R. Okay. And then you can observe that pi radians basically equals to 180 degrees. Okay, pi radians is 180 degrees. And we have this conversion over here. Okay. 1 degree actually is pi over 180 radians. Okay, so this is particularly important when you talk about when you have questions that deal with radians. Okay, I mean so enough when you do with the chapter enough, you'll be comfortable working with radians. But for the most part, I think most people they don't really like working with radians too much. Radians is it's only natural to work with degrees because you kind of have done work with degrees all your life. But then radians have serve a pretty important purpose as well. Okay, as you learn later on. Okay, right now it might seem like a chore. Like when you're solving like trigo equations, you can have so you can solve in degrees, solve in radians. Okay, yeah, radians is really something you have to get used to, especially for those trigo equations that you have to solve in one. Okay, so take note of this conversion. Okay, 1 degree is pi over 180 radians. Then yeah, you can also convert the other way around to find how many degrees is how many radians. Okay. So be familiar with the conversion process. Okay. Yeah. So as I mentioned, you should be able to work with both. Okay. And also one more thing. Sometimes if you have seen some answers, right? They might okay. Usually in like school answers, like you do some paper, then after you look at answers the school provide. Usually they'll say about radians. Okay, but technically radians doesn't have a unit. Okay. So yeah, but I think to just be safe, you should write radians. Okay, but if you don't write, I think they shouldn't penalize because technically there is no unit. Okay. Then now the next concept we should introduce is a trigo function. Okay. So okay, this one I'm sure you have really seen this right in AMath, okay, the Pythagoras theorem and trigonometric ratio chapter, right? So these three shouldn't be too familiar. Okay, the Tokaso, you know how to memorize Tokaso already. Um, so you all have seen it in context of a right angle triangle, right? And you can kind of see, okay, sine theta is opposite over hypotenuse. The opposite length here is going to be BC, okay, then the hypotenuse is AC, okay. And the other two you can kind of see yourself, right? And then to memorize, you typically use Picasso, okay. So I don't think you all should have too much trouble knowing how to use this, okay. But then in AMath, okay, we introduced these three new guys, okay, the so-called reciprocal trigo function. So reciprocal means sometimes it just means one over something. Okay. So okay, we see the corresponding reciprocal functions. So the first one is sine, right? Okay. The first normal function we learn is sine. Okay. So one over sine is called cosecant. Okay, then for cosine, 1 over cosine is secant. And then for tangent, 1 over tangent is cotangent. Okay, so these three guys are so-called the reciprocal trigonometric functions. Okay, and how to tell like okay, which one corresponds to which. Okay, you look at the third letter. Okay, so I'm sure your teacher would have told you this, right? Uh, the third letter is what function it represents. So S equals sine, C is cosine, T is tangent. Okay. Yeah, essentially these are just 1 over the original trig functions. Okay. Any questions so far? Okay, these are the definitions. Okay. So now these trigo functions also there are some special values, right? There's some special values where you put like say 45 degrees, 90 degrees, it gives you some special value. Okay. So we'll look at it in the next part. Okay. So for these special values, right? The special values are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay. So these three guys, these five guys are the special values. Okay. In the ideal case, right, if you can memorize it, that'll be very good. But okay, I tell you, like nobody really memorizes it. So, okay, there are like few ways to memorize it, to help memorize it rather than memorizing it like raw. Okay. Of course, memorizing it raw is not ideal, right? It takes a lot of brain power. Okay. So, I don't know. Do you see these two triangles? See these two triangles? Okay. Like this is one of the ways to like memorize the trigo special values. Okay. So for example, okay, if I want to get okay, if I want to use this guy, I want to find maybe sine of 30. Okay, sine of 30 is okay, 30 is here, right? So sine is opposite over hypotenuse, so root 3 over 2. Okay. So sine of 30 is wait okay, I think it's labeled a bit wrong. Okay. This one I think the change this one should be 60 and this should be 30. Okay. Yeah. So this one should be 60. Okay, apologies for that. Okay, so sine of 60 is opposite, so root 3 over 2. Okay, then uh, if I want to find cosine of 30, okay, cosine of 30 is adjacent over hypotenuse, so root 3 over 2. Okay, is this. Okay, and then for this other triangle, say sine of 45 okay, is opposite 1 over root 2. Okay, then tangent of 45 is opposite over adjacent, so 1 over 1, which is 1. Okay, so that's how you use these triangles to memorize. Okay, but another way to memorize these, okay, I think another thing that you don't really memorize. Okay, the other one is to use a calculator, right? I think some of you will know to use calculator, right? So, but of course, some of the answers are not very nice. So, like maybe if you key in your calculator sine of 30, it gives you half, very easy to see, right? That's 0.5. Okay, but what about this? Okay, if I put sine of 45 degrees, I will get some irrational number, right? Okay, root 2 over 2. So, any ideas? How do I like see this? Square it. Yes, okay, correct. So, Guliang said to square it. Okay, so okay, this guy, right, root 2 over 2, okay, or it's 1 over root 2, then in the calculator, this will be some funny number, right? So if you were to square this, then it will be half, right? Okay, then you can kind of work backwards as to what the value is. Okay. And same with root 3 over 2. So root 3 over 2, you square it, it will be 3 over 4. Then you can kind of reverse engineer. Okay. So that's pretty simple. Okay. Then but the last method, okay, if you don't have access to the calculator, uh, and you don't remember the triangle, okay, I think this is a very good method. Okay. So notice, right, okay, you look at this table below. So actually you can actually write all these numbers as square root of something over 2. Okay, so sine theta, okay, sine theta, sine of 0 degrees is 0, right? So it's actually root 0 over 2. Okay, square root 0 is 0. Okay, then this guy half, right? It's actually square root 1 over 2, which is half. Then this is square root 2 over 2. Okay, same, square root 3 over 2. Then square root 4 over 2. Square root 4 is 2, right? So 2 divided by 2 is 1. Okay, then the cosine actually is opposite, right? So 1, 1, then square root 3 over 2, square root 3 over 2, then 1 over half. Okay, so actually you can see it's an increasing factor. It's square root of something divided by 2. Then for sine, right, it's increasing, and for cosine, it's decreasing. Okay, so I think this is a pretty cool way to memorize it. Okay, if you somehow don't have a calculator and you like don't want to memorize the triangles, okay. And then, of course, if you have sine of some value, right? Okay, sine and cosine of some value, you can calculate tangent, okay? Because tangent, as you might see, is sine over cosine. So let's say I want to calculate tangent of like 30 degrees, okay? Then it's just going to be tangent of 30 degrees is just going to be sine 30 degrees divided by cosine 30 degrees, which is root 1 of, okay, it's just half divided by root 3 over 2, which is 1 over root 3. Okay. And if you rationalize, then it's going to be square root 3 over 3. Okay. Yeah, so that's it for the special values. Okay. Any questions for special values? Okay. Yeah. So those special values. Okay. Three methods I would give you. Okay. First one is the special triangle. Second is the calculator, and third is making this pattern increase and here decrease. Okay. Okay. Then now you all can give this question a try. Okay. Okay. For this one, okay. Let's say without using a calculator, like even if they say you cannot use calculator, you can like sneakily use it to like verify that the value is correct. Okay. Uh, yeah. Preferably you won't use a calculator, but if calculator you can kind of use it to like pretend that you know the value of it. Okay. So this one I'll give you all maybe about 3 minutes to attempt. Okay, this does involve some simplification of certs. Okay, on second thought, okay, I'll give your just now I give three. Okay, so it's each. Okay, until two, maybe at most until 219. Okay, yeah, about 3 more minutes from now. The certs a bit troublesome to simplify. Any issues?
No. I don't know what the question is.
Okay. Okay, Jenna, you may give it an attempt. Okay, let's go through this one. Okay, so okay, for the values, you can really just refer to the previous page if you want, but yeah, or as you can do what I mentioned, right, is to just kind of construct a table. Okay, this is how I usually like to do it. Okay, I'll use calculator if it's accessible. That's the best way. Okay. If it's not accessible, then you can just construct this pretty easily. So these are the special angles. So 0, 30, 45, 60, 90. Okay. Then this is sine 0 is 0. And this is 1 over root 2. Then this is uh yeah. Wait, sorry, this is half. This is 1 over this is like root 2 over 2. 1 over I'll just rationalize that. Root 2 over 2. Okay, then this is square root 3 over 2, and then this is 1. Okay, then here opposite the other direction, so it's 1, then root 3 over 2, root 2 over 2, this half, and this is 0. Okay, so sine of 60 degrees is going to be root 3 over 2. Okay, then cosine 45 is square root 2 over 2. Then tangent 30, okay, tangent is sine over cosine, right? So, okay, tangent 30 degrees, we work on the side, is equal to sine 30, which is half over cosine of 30, which is root 3 over 2. Okay. So the 2 here cancel, so it's going to be 1 over square root 3. Okay. But 1 over square root 3, we rationalize it, multiply root 3 over root 3 on the top and bottom. Then this will be square root 3 over 3. Okay. So any issues with getting these three values? These three values, okay, this is how you get the three values. Okay, then afterwards is to very rationalize. Okay. So once you have these three values already, then you have to get rid of the fractions. So get rid of the fractions, you make everything the same denominator. Okay. So the top has a denominator of 2, the bottom has a denominator of 2 and 3. So you want to combine these two fractions first. Okay. You combine these two guys, the denominator becomes 6. Okay. Then the goal now, right, is to remove the fractions. Okay. So the top there's a fraction, the bottom there's a fraction. So to remove the fraction, you can multiply the top and the bottom by 6. Okay. You can multiply the top and the bottom by 6. Then you will get this. Okay. But of course, this is not finished yet because it's you should always try and rationalize when you can. Okay, but I think I hope that the rationalization step shouldn't be too like hard to see. Okay, I'll show the answer here. Okay, once you manage to simplify the fraction into maybe I think once you get to this step already, then the rationalization is just algebra. It's still too difficult. Okay, any questions? Okay, so yeah, this does involve some certs. Okay, so yeah, we'll brush on certs as well. Not too good, not too confident on it. Okay, yeah. This chapter also you will be dealing with fractions on like fractions inside a fraction. So okay, the main idea if you're dealing with fraction inside a fraction is to try and get like remove the fraction. Right? So here on top there's a fraction, below there are two fractions. So your goal is to try and make there be only one fraction, which is the big guy. Okay, the top and the bottom right should not have fractions in each other. Okay, and to do that, you multiply by the LCM. Okay, so it's a common technique. Okay, then now look at part B. Okay, so part B is now is in radians. Okay, but don't be too afraid of working in radians. So we know that pi radians is 180 degrees, right? Pi radians 180 degrees. So pi over 3 means 60 degrees. Okay, hopefully you can see that. So pi over 3 is 60 degrees. Okay, so therefore we want to find tangent of 60 degrees. Okay, tangent 60 degrees is sine 60 degrees over cosine 60 degrees, which is sine 60 degrees is root 3 over 2, and cosine 60 degrees is half. Okay, so the 2 and 2 cancel, so it's basically going to be root 3. Okay, so this is root 3. Then cosine of pi over 6. So pi over 6 is 180 divided by 6. So it's 30. Okay, so cosine of 30 is root 3 over 2. Okay, then sine pi over 4 is root 2 over 2. Okay, so we have these three values and then we can sub it in. Yeah, I think this one don't really need to rationalize. It's much simpler. Okay, so you see these values, right? So tangent pi over 3 is root 3, cosine pi over 6 is root 3 over 2, and sine pi over 4 is square root 2 over 2. Okay. You don't even need to rationalize anything here. You can just combine the fractions. Okay. Here, I guess we do use the fact that square root a times square root b equal to square root ab okay, to make it a bit nicer. Okay, yeah, so definitely part A is more challenging here because you need to deal with fraction inside a fraction and then you need to rationalize afterwards. Part B is simple business. Okay, so always try and rationalize. When you can rationalize, you should rationalize. Okay, rationalize meaning if you assert the denominator, you multiply the top and the bottom by the conjugate. Okay, any questions? Okay, then next, okay, when we are given a triangle, okay, we can use the trigo ratios, right? The trigo ratios that we are familiar with, okay, in a right angle triangle. Okay. So given that theta is an acute angle such that tangent theta equals to 4 over 3, I'm asked to find sine theta, cosine theta, cosecant theta, and sine of 90 degrees minus theta. And lastly, deduce the relationship between sine of 90 degrees minus theta and cosine theta. Okay. So for this kind of questions, right, you can what you do is just draw a triangle, draw a right angle triangle. Okay. Then what do we know? We know tangent theta is 4 over 3. Okay, and tangent is opposite over adjacent, right? Okay. Opposite over adjacent, tokaso. So this means that opposite must be 4 and adjacent must be 3. Right, you can see that. So 4 over 3 means opposite is 4 and adjacent is 3. Okay. And then if you have opposite and you have adjacent, right? Okay, you have opposite and adjacent, then how do you find the hypotenuse for a right angle triangle? How to find the hypotenuse? Any ideas? You have two sides of the triangle and you want to find the last one. It's a right angle triangle.
Pythagoras.
Yes, Pythagoras. Okay, good. Yeah. So use Pythagoras theorem. So square root of 3 squared plus 4 squared, which is square root 25, which is 5. Okay. This guy over here. Okay. Okay, then we can go and solve all the questions already. So sine theta is opposite over hypotenuse. So theta is this one. So sine theta is opposite over hypotenuse. So it's 4 over 5. This one will be 4 over 5. Okay. Cosine of theta. So cosine is adjacent over hypotenuse. So theta is here. So adjacent is 3 and the hypotenuse is 5. So it's 3 over 5. Okay. What about this? Cosecant theta. Okay, cosecant theta is 1 over sine theta, right? Okay, cosecant is 1 over sine. Okay, and we actually know the value of sine is 4 over 5. So 1 divided by 4 over 5, you flip the fraction around, so it's 5 over 4. Okay, so that's 5 over 4. Okay, then for part D, okay, part D, sine of 90 degrees minus theta. Okay, so where is this angle exactly? Okay, I mean it's in the diagram already, but you can imagine this is theta, then this is a right angle triangle, 90 degrees, right? So if you use the sum of angles in a triangle, you can see that the last angle here is 90 degrees minus theta. Okay, so this last guy is 90 degrees minus theta. So sine of this is opposite over hypotenuse. So it's actually 3 over 5. Okay, this one is 3 over 5. Okay, so actually, then lastly, the last part say, deduce the relationship between sine of 90 degrees minus theta and cosine theta. Okay, cosine theta we calculated earlier at 3 over 5. And sine of 90 degrees minus theta is also 3 over 5. Okay, so the relationship is that they are equal. Okay, the answer is that they are equal. Okay, yeah. Any questions about this? Okay, so just take note for these questions, this picture will not be given. The picture is like you also draw, right? Okay, but once you see this style of question, you can draw a picture like this to solve the problem. Okay. But take note, this is only when it's acute. Okay, if the angle is acute, then it's very simple. But if it's not acute, then you might need to consider other things. It can be negative also, right? You would have seen some examples where it's negative. Okay, and here there's a little fact, okay, about complementary angles. So what is a complementary angle? Complementary angles are angles that add up to 90 degrees. Okay, so these are three like identities. Okay, you all would kind of know this concept of identities. Okay, so yeah, of course, I think these three you don't really need to memorize it. Okay. Later on you learn the addition formula, kind of use it if needed to use it. Yeah, but this is just good to know. Okay. Alright, then now you all can give this question a try. So I give you all maybe like 2 to 3 minutes to solve. Okay. Um, yeah, once again, it's very similar to the previous question. Just make sure you draw a triangle, triangle, then find the last side. Oh, some break overs. 7. Is it module for?
Yeah, just I mean that on the color. Yeah.
Yeah.
This will come here because like the previous lipstick is like all the it's not really nice.
Okay. I think the triangle should look like this. Okay, so okay, that's a clue, right? Cosine theta equals to k means it's k divided by 1. Okay, that's what I did. Okay, I still free the like okay, I think once you have 1 and k, then it's the other side should be 2 to find. Okay, so this is the trick. Okay, the trick that I use is k just k divided by 1. So adjacent is k and then the hypotenuse is 1. Any issues? Okay, can. Okay, can. Then we go through this one, right? So the trick here is really that they just say equal to k. I mean, it's not very obvious what it means, but it just is basically k divided by one. Okay. So cosine theta is k divided by one. So that's adjacent, which is k over hypotenuse, which is one. Okay. Then use Pythagoras theorem to find that this is square root of one minus k squared. Okay. Yeah, then the first part, find sine theta. Okay, sine theta is easy, right? Theta is here, so sine is opposite over hypotenuse. So square root of 1 minus k squared over 1, which is square root of 1 minus k squared. Okay, then for part B, find tangent theta. So tangent is opposite over adjacent. So square root of 1 minus k squared over k. Okay, then lastly, okay, cotangent theta. Cotangent theta is just 1 over tangent, so it's just flip around k over square root of 1 minus k squared. Okay. So this one, if you want to rationalize, you can also. This one. Okay, if it's like an actual number inside and you rationalize, I think it's definitely that's the case. But this one, because it's unknown, you can leave it as such. Okay. Any questions about this? Okay, yeah. So as I said, the main trick is really just the fact that it's k over one. K instead of writing as a fraction, because most of the time you see it as a fraction, and it's very obvious. Okay, then moving on. Okay. This portion here we talk about reference angles. So the reference angles, okay, is will be very useful when you're solving especially trigo equations. Okay. But this can be also used to solve these type of questions. The type of question we just did is very much solvable with this also. Just that okay, we've always been now we've only been dealing when theta is acute. But of course theta need not be acute, it can be obtuse, can be reflex or whatever, right? Okay. Okay, so the quadrants are defined as follows. So the first quadrant is from 0 to 90, then second is from 90 to 180, third is 180 to 270, and the fourth is from 270 to 360. Okay. So how does it work? Okay, you go from your positive x-axis, then you go anti-clockwise. Okay, anti-clockwise. Yeah. And a negative angle is when you go clockwise. Okay, clockwise like that. Okay, from the x-axis, positive x-axis. Okay. Okay, so what is a reference angle? Okay, so this for each of these diagrams here, right? There is an angle that is always acute. Okay, acute meaning is from 0 to 90. So for each of these red angles over here, right? This alpha, the blue color angle, is called the reference angle. Okay, and the reference angle, okay, unlike these angles which we usually measure with anti-clockwise, right? The reference angle can be can be measured clockwise. Okay. Can be measured clockwise. For example, for the fourth case, okay, the one at the bottom right. Okay. Yeah. So this can be used to solve this style of questions. Okay, we'll see in a little bit, right? Okay. And yeah, reference angle important is always acute. Um, yeah, okay, I think we can see an example. Okay, okay, not yet, not quite yet. But how do we obtain the reference angle? Okay, so for if the angle is in the first quadrant, right? If the angle is in the first quadrant, then the reference angle is exactly equal to the angle itself. Okay, so in this case, the like it's overlapping, but the theta and the alpha are exactly the same. Okay, then what about if it's in the second quadrant? Okay, the second quadrant, the alpha is here. Okay, so how to get alpha is actually 180 degrees minus theta. Okay, and it is a third quadrant. Okay, the third quadrant is well, if theta is the third quadrant, then the reference angle is theta minus 180 degrees. Okay, and for the fourth quadrant, okay, now we need 360 degrees minus theta. Okay, you get this angle here. Okay, so for as I think for these four guys, okay, I find it, I think it's quite troublesome if you go and draw the picture every time. So if possible, just memorize. Okay, because this is particularly useful for trigo equations where let's say the angle belongs in like the first and third quadrant, then how do you calculate the corresponding angles, right? With the reference angle. Okay. So of course we'll look at it in it's one of the later parts of the chapter soon. We'll look at it soon. Okay. But for now, it's a good practice to just memorize this. Okay. I think you all probably would have this memorized. Do you memorize like this like angles? Okay. Yeah. And of course there are there's an ASTC thing, right? Which quadrant in what trigo identity is positive. Okay. So in the first quadrant everything is positive. The second quadrant only sine, third quadrant tangent, and fourth quadrant is only cosine. Okay. Um. Okay. The next portion will justify as to why it is. Maybe we can look at a case. Okay. Maybe for quadrant three. Okay. For quadrant three, let's say you have an angle in quadrant three. Yeah, quadrant three. Maybe like this. Okay. So in quadrant three, okay, what is going to be positive? What's going to be negative? So actually, if you have a point here, right? If you have a point here. Okay, you see that the x at this point here, the x coordinate is negative and the y coordinate is also negative, right? You can see, so it's here and here. Okay, so let's label this as maybe like minus a minus b. That's what they use, right? Okay, yeah. So if this is minus a comma minus b, right? Okay, then your angle here is theta. Then sine of theta is then this length here is basically minus b, this is minus a. Okay. Sine of theta is opposite over hypotenuse, right? So opposite, and if my hypotenuse is just 1, right, then it's just minus b over 1, which is clearly negative. Okay. Then cosine is adjacent over 1, minus a over 1, which is also negative. Okay. And tangent, however, tangent is opposite over adjacent. So negative over negative, then it's positive. Okay. So okay, this one is very just to justify why like maybe in the third quadrant only tangent is positive. Okay, but of course you don't need to go and derive this. Okay, if you memorize ASTC, that's good enough. Okay, so for this portion, things to memorize really is just how to calculate the theta based on the reference angle. Okay, for each of the quadrants, and then secondly the ASTC, which quadrant, what angle is which trigo function is positive. Okay. Now we look at how to solve this kind of trigo ratio problem. So this is a trigo ratio problem that we just did, right? The trigo ratio problem. Okay. So now we can solve it in two ways. Okay. Using these reference angles and using just the basic method. Okay. And in general, theta might not be acute. Okay. Just now we always did for when it's acute. Okay. When it's not acute, then it's slightly more complicated. Okay. So look at this example here. Okay. So now this angle here is in the second quadrant, so it's no longer acute. Okay, it's no longer acute. So we're asked to find sine theta, cosine theta, and tangent theta. Okay, and theta is this blue color angle here. Okay. So okay, the first step really is to just calculate. Okay, we know that this is minus 3, 4, right? Okay. So this distance here is going to be 3 and this is going to be 4. Okay. Then the easy to calculate, right, is the hypotenuse. Use Pythagoras theorem. Hypotenuse is 5. Okay, hypotenuse is 5. Okay. Then now we can use two methods, right? The reference angle method and then just calculating straight away. Okay. So I think we look at the reference method first. The reference angle. Okay. So the reference angle for this one, right, is going to be this guy. This one here. And maybe I use red color. Reference angle is this guy, is acute angle. Okay. So for this acute angle, okay, for this acute angle, I can calculate the trigo ratio, right? So like let's say I want cosine of alpha, okay. Then adjacent is this one, which is just 4, and hypotenuse is just 5, right? We calculate it to be 5. Okay. Wait, did I say cosine? I think I said cosine, right? Then okay, cosine is actually adjacent to 3, and here's 5. Okay. Then sine will be 4 over 5, and tangent will be 4 over 3. Okay. So that's not difficult to calculate. Okay, if we just use the reference angle. Okay, then now how do we relate the reference angle to each of these guys? Okay, so okay, for part A, okay, we want to calculate sine theta. Okay, so for right now, right, we are only looking at alpha. We're looking at alpha. Let's look at part A, sine theta. Okay, so theta is in the second quadrant, right? Theta is in the second quadrant. So if theta is in the second quadrant, means if you see ASAC, okay, AS. So in the second quadrant, sine is positive. Okay, so sine theta is simply just going to be the same as sine alpha. Okay, then what about cosine theta? Okay, cosine theta, AS, right? So only sine positive. In the second quadrant, cosine will be negative, right? Okay, so cosine theta will be negative of this guy. Okay, then tangent, okay, same thing. Tangent will, in the second quadrant is negative. So it will just be negative of this guy. Okay, I understand how it works. Okay, so you basically calculate for the reference angle the three trigo identities or functions, the ratios. Then you see the sign, right? Which quadrant is it in? Then you apply the sign afterwards. Okay, so this is method one. Okay, method one is with using the reference angle. Okay, then method two you can just is skipping all this stuff. Okay, you can just calculate straight away. Okay, so okay, for method two, okay, then method two, let's say you want to find okay, just sine of 4/5. Okay, sorry, sine of theta. So now you consider the actual values that have signs on it. So this is 4 and this is -3. Okay. So sine of theta, okay, is just going to be opposite, which is 4, over hypotenuse, which is 5. Okay. Then cosine of theta is going to be, okay, now you consider the sign. So there's a negative sign over here. So that will be -3 over hypotenuse, which is 5. Okay, then lastly, tangent theta is opposite is 4 and adjacent is 3. So -4/3. Okay. So the reference angle method, right? When you're doing it, don't consider the signs. Okay, so you see once again, right? Cosine of alpha is 3/5. Okay. But then in this picture here, actually it's -3, right? Okay. But in the reference angle, you don't care about the sign. Okay. The sign will always be positive. Okay. If this is -3, just treat it as 3. Okay. But then if you use the second method here, you consider the signs. Okay. So that's why cosine of theta is -3/5. Okay. Any questions for this? Okay. Then you can give this question a try. Okay. This one is a third quadrant. This one maybe about 2 to 3 minutes. Alright, done. Okay, generally, any reviews? Okay. Okay, so for this guy, okay, we can consider two methods again. Okay. So the angle should look something like this one. Okay. And draw this, it's fine if you draw it. It's fine if you don't draw it. Okay. Okay, so let's first consider the reference angle method. Okay, the reference angle method. So reference angle method is this will be alpha. Okay. Then this will be 3. Okay. Use Pythagoras theorem. Or you can just memorize if the hypotenuse is 5 and one of the sides is 4, then the other side will be 3. Okay, or use Pythagoras theorem. Okay. So for alpha, okay, we asked to find sine theta and tangent theta. So we should find sine alpha and tangent alpha. Okay, sine alpha is alpha is this one. So opposite 3 over 5 hypotenuse. Okay. Once again, don't care about the signs. Okay. This actually should be minus 3 because it's below the x-axis. Okay. Then tangent alpha is going to be opposite over or opposite over adjacent. So 3 over 4. Okay, 3 over 4. Then now, okay, this angle is in the third quadrant. Okay, AST. Okay, so in the third quadrant, only tangent is positive. So that means sine theta, right, should be minus 3 over 5. Okay, it's just going to be the same guy, but you put minus sign in front because it's negative. Okay, but then tangent is positive in the third quadrant. So AST, that means tangent theta will actually just be 3 over 4. Okay. So this is how you would do it using the first method. Okay, so method 1. Okay, then for method 2, you consider with the signs. Okay, so method 2, okay, we want sine theta, right? Sine theta is opposite over hypotenuse. Okay, so now we care about the signs. So opposite is this one, hypotenuse is this one. So minus 3 over 5. Okay, then tangent theta. Okay, tangent is opposite over adjacent. So it's minus 3 over minus 4, which is minus 3 over 4. 3 over 4. Okay. Yeah, so you see both methods will of course will give you the same answer. Okay. Personally at least for these type of questions, I'll just do method 2. Method 2 is easier. Right? Method 2 is just care about the science. Okay. Method 1, okay, is not particularly it's a bit longer for this portion of the chapter, but later on when you're solving trigo equations, then it's more useful, I guess. Okay. Okay, then the next portion, all right. If we want to calculate exact values using reference angles, okay. So okay, let's look at part A first. Okay, without using a calculator, evaluate cosine of 120 degrees. Okay. So this is the type of question where you need to have knowledge about reference angles, not you cannot complete. Okay. So 120 degrees is in the second quadrant. Okay, right? It's more than 90 and less than 180. Okay, 120 degrees in the second quadrant. And in the second quadrant, ASTC, right? So second quadrant is cosine is negative. Okay. Then the reference angle is going to be right from the previous from this table over here. We see that reference angle is going to be 180 degrees minus theta, where theta is 120. Right? So the reference angle is 60 degrees. Okay. So this means cosine of 120 degrees, right? Okay. We know it's less than 0, so there will be a negative sign. Okay. So minus cosine alpha. Okay, and the alpha is 60 degrees, so it's minus cosine 60 degrees, minus half. Okay, and then this one, 210 degrees. Okay, 210 degrees is in the third quadrant. Okay, and AST. Okay, so that means tangent 210 is positive. Okay, then the reference angle is going to be theta minus 180 degrees, which is 30 degrees. Okay, then now we look at this. Now we say it's positive, right? So there's no negative sign in front of the alpha. So tangent 30 degrees, which is root 3 over 3. Okay, once you rationalize. Okay. Then finally, for part C, okay, 7 pi divided by 4. Okay, so of course, like even even for me, right, I cannot tell what quadrant 7 pi over 4 is. Okay, what, but you can't easily tell what it is. So to be able to tell what quadrant it is, just in your calculator, right, we know that pi is 180 degrees, right? So you just calculate 7 times 180 divided by 4. Okay. You calculate it, you see it's between 270 and 300. It's in the fourth quadrant. Okay. So if it's in the fourth quadrant, ASTC, okay, so sign is negative, right? Okay, then the reference angle is 2 pi minus theta, which is pi over 4. Okay, so sine 7 pi over 4 is going to be minus, okay, so what's less than 0? Minus for sine alpha, and alpha is pi over 4. Okay, so the answer is minus root 2 over 2 once you rationalize. Okay, any questions for this? Okay, so quite a lot of steps, okay, but if you know what you're doing, then I don't think it's too difficult. Okay, a kind of note here, I don't think this one is too important, right? The angles you can also measure, okay, usually you measure anti-clockwise. Anti-clockwise angles are positive, okay, but if you measure in the clockwise direction, then it's negative, okay. So there are these three identities, okay. I don't think it's too important for now, okay, yeah, if it's necessary to use, then refer to it later, okay. For O-level standard, I don't really think it's necessary. Okay, yeah, for this one, yeah, this is ignore. Okay, but I guess if you want to look at the picture, it kind of will tell you how to derive it. Okay, if you draw theta, like the theta is the angle that's measured anti-clockwise, and the negative theta is the same angle, but like you can't reflect it downwards. Okay, reflect it downwards. Okay, refer to it if you want to. Okay, won't really be tested too much. Okay, okay, this portion is a bit more challenging. Okay, it's a bit more challenging, but if you all can do it, then it shows that you understand the previous part pretty well. Okay, you might have to use some of these identities as well, the ones on top here. Okay, but really, is what you probably have to do first is to break it down into the normal trigo function. Then the normal trigo function, you see, okay, is it in the third quadrant, positive, then you calculate the reference angle, all that stuff. Okay. This one maybe about 4 minutes. Okay, I'll say it's very not easy. So like if you all need any help, then feel free to ask. Okay. Alright. Okay, we're now done. Okay, of course these are not very simple questions. But okay, if it's like more or less simple, then I'll tell you that. But like this one it's not. It's pretty tough. Okay, so we have two methods to solve this. Okay, we have two methods to solve this reference angle or the identities method. Okay, so perhaps for the first one, we will try using just the reference angle. Okay. So minus 330 degrees. Okay, so three like in the normal case, okay, let's see like a quick sketch here, a quick sketch of what this might look like. So in the normal case, 330 degrees will look like this, right? If you like you measure anti-clockwise, so it'll look something like this. Okay. Something like this. Okay. But minus 330 degrees means you go from the clockwise direction instead. So actually, instead of being in the fourth quadrant, you will be in the first quadrant. Right? This is going to be theta. Okay. So it will be in the first quadrant. Okay. So in the first quadrant, okay, then the reference angle will be this guy. Alpha will be this. Okay, which is just going to be 30 degrees. Right? Because this is 330, then 330 plus 30 is one whole circle, 360 degrees. Okay. Okay, then one more thing we know in the first quadrant, everything is positive. ASTC, right? First quadrant, everything is positive. So we know that actually okay, but before that, right? Okay, we should probably simplify. Right? So cosecant actually is 1 over sine. Okay. So cosecant of minus 330 degrees is 1 over sine of minus 330 degrees. Okay. And for sine for this function here, the reference angle is 30 degrees. Okay, 30 degrees. So our goal is to really find sine of 30 degrees. Okay, sine of 30 degrees, we know it's going to be I think half, right? Okay, sine of 30 degrees is half, right? Okay, it's half. So then we know in the first quadrant, as I said, right, everything is positive. So essentially, your answer is just going to be 1 over half. Okay. So two things are okay. Find the reference angle. Reference angle is 30 degrees. Okay, and then the sine is fine. Okay. First quadrant, everything positive. Okay, so this is 1 over sine 30 degrees. Okay, which is 1 over half, which is 2. Okay. Any questions about this? Okay, so this is using a reference angle. Maybe for part two, okay, for part two maybe I will use the above one of these above formulas. Okay, that's just to show you a variation. Okay, in the end you still need to consider the quadrant and stuff. That one you cannot escape. Okay, so okay for part two, we're asked to find secant of minus 135 degrees. Okay, so the first step, okay, never deal with this kind of inverse trigo or reciprocal trigo function. So secant, right, of minus 135 degrees actually is 1 over cosine of minus 135 degrees, right? Okay. So our goal is to find cosine of minus 135 degrees. Then we can solve this. Okay. Or then for in this case, maybe I want to use the above formula. Okay. Which says that cosine of minus theta equals to cosine of theta. Okay, cosine of minus theta equals cosine of theta means I can basically remove the negative sign. Okay, so this thing will be equal to 1 over cosine of 135 degrees. Oops. Okay. Then cosine 135 degrees is where? Okay, it's actually in the second quadrant. Okay, somewhere here. This is a theta. Okay, and the alpha is here. Okay, so 135, okay, that means this alpha must be 55 degrees. Okay, it must be 55 degrees. Uh, sorry, 45. Okay, first theta is 135, then to complete 180 degrees, this guy must be 45 degrees. Okay, so now cosine 135 degrees, right? Okay, AS, okay, second quadrant means cosine of 45, means cosine of 135 degrees is negative, less than 0. So there must be a minus sign. Okay, and cosine of 45 degrees is root 2 over 2. Okay, so now there's a minus sign, and it will be minus cosine of 45 degrees, which is 1 over minus root 2 over 2, okay, which is 1 over root 2, okay, which will be equal to minus of square root 2. Okay, so this method is, I'm using this formula over here to simplify the negative angle into a positive angle first. Then afterwards I use the reference angle. Okay. So in the end, you still have to use the reference angle. Okay. But perhaps if you like working with positive angles, then this is the way to go. Okay. Then for the last one, okay, the last one I will show the working, right? Okay. So what's the difference? Last one is in radians. Okay. So if it's in radians, right, you should probably try and find the degree equivalent. So 5 times 180 divided by 4 will be 225. Okay. 225 degrees is going to be positive. No, 225 degrees, sorry, it's going to be in the third quadrant. Okay, third quadrant, then tangent is AST, so tangent is positive in the third quadrant. Okay, but this is negative first. Okay, let's see a calculation. Okay, so the tangent function, okay, so minus 225 degrees will be in the second quadrant. If you go from the, it'll be second quadrant because once you go here, then it'll be in the clockwise direction. Okay. So therefore, tangent second quadrant, right? AS, so sine will be positive. Tangent will be negative. I mean, okay. And then the reference angle will be 45 degrees. Okay, it will be 225 minus 180. Okay. And thus, okay, cosine of minus 5 pi over 4 is 1 over tangent of minus 5 pi over 4, right? Okay. Then because it is negative, we put a minus sign outside. And then the reference angle is tangent pi over 4. So tangent pi over 4, then the answer is minus 1. Okay, any questions about this? Okay. So if you see this, I would recommend just using the reference angle formula. On top of these formulas, you don't really care about this. Okay. Just make sure if you see negative angle, measure clockwise, don't measure anti-clockwise. Okay. Yeah, I think we can have a 5 minute break, then we will continue with graphs. Okay. Yeah, I think the later portions maybe I go a bit faster. Okay. This one, the fundamentals, like making sure you all understand fully. And the next portion one, if your fundamentals are good, Yeah, I don't think it should take too long. Okay. We'll come back at 3:15.
The tangent for this graph, my translate is not that stuff.
Oh yeah, you don't need to draw tangent graphs, the sign has to. But you should know what it looks like. You learn R formula, right? R formula is okay. Okay, we can resume. Okay, I think next portion is about sketching graphs. Okay, trigo graphs and sketching. Okay, so for trigo graphs, right, we really want to be sketching sine and cosine. Okay. So could you say your like teacher like say is like confirm or tested trigo like tangent. Okay. Yeah. So tangent I'll still like go through like we won't really spend much time on it. The sine and cosine is still the most important one. Okay. So here we see the two examples of the common trigo graphs, okay, sine and cosine. The top is sine and the bottom is cosine. Okay. So there's some terms that you should be familiar with, alright. Amplitude and period. The amplitude is so-called the displacement from the origin to the either highest point or the lowest point. The origin is kind of like this line here. Or the other way to calculate the amplitude is you add the top and the bottom. You find this distance, you divide by 2. That gives you the amplitude as well. So the period is the amount of like kind of like the time it takes to complete one full wave. Okay. So for sine, one full wave looks like this. For cosine, one full wave looks like this. Okay. So the period in let's say if you complete 2 cycles, right, then 2 cycles look like this. Okay. And for cosine look like this. Okay. So when you're drawing a graph, you should calculate the amplitude and period are very important to calculate. Right. Then it tells you maybe from this particular range how many cycles you need to draw. Okay. And the cycles need not be a whole number, it can be like 1.5. So for example, 1.5 of a sine cycle will be 1 cycle, then 1.5 cycles, okay, like this. Okay. And that's another thing that we calculate, not calculated, but it will be given as well, is a vertical shift, right? It's a plus C, okay, which will tell you whether the graph goes up or down. Okay. So the period, okay, the formal definition is defined as the half the difference between the maximum and minimum value of the graph. It's always positive, the amplitude, okay. So in here, right, okay, the difference is obviously 2, when you divide by 2 is 1, so the amplitude is 1. Okay. And the period of the graph is the smallest length of interval where the graph repeats itself. Okay, this is how I don't really spend time on it. Okay. And either you observe, okay, for each of the graphs, answer the following. Which values of x is the function equal to 0? So you can see from here, okay, for sine x, it will be 0, it will be 180 degrees, it will be 360 degrees, 540, 720, okay, blah, 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 for sine. Okay, and don't forget the negative portion also, negative portion, all of this. Okay, and for cosine, you can see also, okay, for cosine, this will be 90, this will be 270, 450, 630, I think, yeah. And of course, don't forget the left and right side of the graph. It's kind of like mirror images, right? Okay. Then minimum and maximum values of the function, right? You can also easily see. Okay, maximum value occurs at 0, 360, 720 for sine. For cosine, that's for cosine. For sine, it will be 90, then 450, etc., etc. Okay. And then both graphs amplitude 1 and the period 360 degrees. Okay. But in general, your graphs obviously do not the periods and the amplitude will not be just 1 and 360 degrees. Okay. So as you can see, okay, the sine and cosine graph, you can kind of see, right? It's they look very, very similar. So actually the sine graph is the cosine graph shifted a bit, and the cosine graph is the sine graph shifted a bit. Okay. That's FYI. Okay. So now tangent, okay, tangent looks a lot more strange. Okay, there's this funny like S shape, but then it does not connect to each other. So these lines here, they're okay, not very necessary for level, but it's called asymptote. Okay, asymptote basically does not touch the graph will never touch the line at these points. Okay. So why are there asymptotes? Okay, the reason why they're asymptotes is because your graph, right, or tangent, right, is sine over cosine, right? Alright. And of course, there are some values when cosine x equals to 0. I think cosine of 90 degrees is equal to 0. Right? Okay. So imagine when cosine 90 degrees equal to 0, then sine x, okay, some number, I think it's 1. 1 divided by 0 is undefined, right? So that's why at this particular point, the asymptote does exist. Okay, because the cosine is not defined. Okay. So there are actually other graphs that have this property as well. For example, your ln x, okay, exponential graph, all this stuff like if you were to draw it out, then there will be some of these points. Of course, not too necessary to know them. Okay. So these graphs, right? These three graphs, okay, the sine, cosine, and tangent. These are the like very basic, the most basic kind. But of course, when you ask to sketch, it will be a bit more different. Okay. We'll look at a sine bx plus c and a cosine bx plus c. Okay. A tangent bx also. Tangent, I'll just go through very quickly because yeah, I don't think it'll be tested as well. Okay. So now we look at this first two, sine and cosine. Okay. So for a sine one, okay, we look at the red color. Okay, on top is cosine. Okay, so we look at cosine. We look at the red color one first. Okay, so we know that the typical shape, right, is like that. Okay, the typical shape for one cycle looks like this. Okay, so in one cycle, you can basically divide it by 4 sections. Okay, the first section is like this. Second one is like this. Okay, so yeah, you divide in 4 sections. So first one is like that, second one is here, third one is here, and fourth one is here. Okay. Okay, so the very first thing you need to calculate, or yeah, very calculate, right, is the period. Okay. So in your function, which will be given in this form, right? To calculate the period, all you need to do is take 360 degrees divided by b, okay, or 2 pi divided by b. Okay, that will give you the period. Okay, so in this case, 360 degrees divided by b, right? Whatever this value is, as you can see, right, is the time it goes from 0 to 360 degrees divided by b. In this x value, right, you complete one whole cycle. Okay, so that's what b does. Okay, you need to calculate the period. Okay, then a gives you the amplitude, which is the distance from the origin to either maximum or the minimum point. So it's either of these values. Okay, this is the amplitude. Okay, but then here there's this plus c also. So this plus c, right? If it's positive, it will shift the graph up, the whole graph by c units upwards. Okay, and if it's negative, it will shift down. Okay, so you apply each of these things, then you'll get a final graph. Okay, and one more thing, it's possible to have a negative sign in front of a also. Okay, but the amplitude, as I said, is always positive. So don't ever say amplitude is minus or something. Okay. This minus sign, the minus sign here, what it does is basically just flip the graph. Okay. So this is the normal graph that you are used to seeing. Okay, the minus sign will essentially just flip everything. Like the highest point become lower, so the lowest become highest. Okay. And for sine, it's basically the same thing. Sine, okay, the amplitude is the number in front of the function. Okay. The period is 360 degrees divided by b, and the c allows you to determine whether it shifts up or down. Okay. And then if there's a minus sign, then it gets flipped. Okay. Tangent, right? Okay, tangent. The only thing I will really say is that the period is one, instead of 360 degrees divided by b, is 180 degrees divided by b. Okay, for tangent. Okay. Any questions for this? Okay. So these are the general graphs. Okay. Really the steps, right? Okay, as I mentioned, find the period. Okay, 360 degrees divided by b for sine, cosine, and 180 degrees divided by b for tangent. Okay. Then you determine in your range, right, how many periods are there, or how many cycles are there. Then what I like to do is to find the minimum and maximum values. Okay. For sine and cosine, the minimum will be the amplitude minus of the amplitude plus c, okay, where c is a shift, and the maximum will be a plus c. Okay. Then you sketch the normal graph. Then if you have a minus sign in front, you reflect it. Okay. And if it's so you sketch the shape here. The shape mixture is constant. Okay. The shape mixture is constant. Then once the shape is done already, right, then you can apply the shift. Okay. If c is positive, you shift up. C negative, you shift down. Okay. Then you label the axis. Okay. XY axis, the minimum maximum value, and then equation of the function and of each period. Okay. So if these are convenient to label, just label them. Okay. So yeah, the bottom tip. Okay, you can actually divide each of these functions into 4 sections. Okay. Once again, for sine is 1, 2, 3, 4. For cosine is 1, 2, 3, 4. So let's say if you're asked to sketch 1.25 of a cycle, you know what to do, right? Means you sketch like this, then you sketch another guy that goes below, and then there's 1.25 of a cycle. Okay, so this example here, okay, there's a lot of text, okay, but what do we do? Okay, amplitude and period. So amplitude is 4, period is 360 degrees divided by 2, is 180 degrees. Okay. Minimum value is minus of amplitude plus c, so minus 4 plus 3, which is minus 1. Okay. The maximum value is amplitude plus 3 plus the c, which is 4 plus 3, which is 7. Okay. Then we can sketch the graph. Okay. Then from minus 180 to 180, okay, we need the period is 180 degrees, right? So you can imagine on the left side of the graph, from minus 180 to 180, there is going to be one cycle. And from 0 to 180, it's going to be another cycle. Okay, actually, yeah, the working here is not complete. It should have another guy down here. Okay, it should look exactly the same. So if I ask you to sketch from minus 180 to 180, okay, okay, never mind. The completed one is at the end. Okay, so but this is what it looks like for the right side. Okay, the left side will just be mirrored. Okay. Then once you have the shape already, then you move it up by 3 units, and then afterwards you're done. Okay. Okay. Sorry, you're not exactly done yet because here, right? This portion they say minus, right? Okay, so minus means you need to reflect it. So okay, the shape, the normal shape, right? When it's positive, 4 cosine 2x plus 3, right? Will look like this. Okay, the one at the bottom, it will look like this. But then if it's negative, right, means it will look like this. It's something like this. Okay, as you can see from the next page. Okay. If the sign in front is negative, then it will reflect. Okay. Okay, any questions for that? Okay, so you can see it's pretty troublesome. Okay, usually in exams there won't be negative sign in front, but if negative sign in front, they probably give you a bit more marks. Okay, so very quickly again. Okay, find the period, find the minimum maximum values, then you sketch the shape of the graph. Then if the shape is correct, then you determine whether you're going to shift up or down with the C. Okay, those are the general steps. Okay, and give this one a quick try. We got 3 minutes. Almost done, right? Okay, Janelle should almost done. Okay. So this one, there are few steps. I'll show the recommended steps. I'll do once again. So first we identify A, B, and C. So A is 5, B is 3, and C is -1. Okay. So the period is simply just going to be 360 degrees. Okay, yeah. In this case, radians. So I'll use radians. Pi divided by 3 with 60 degrees. Okay. So here I'm asked to draw from 0 to pi. 0 to pi. Okay, and the amplitude is 5. Okay, so if the period is pi over 3 and I'm asked to draw from 0 to pi, right? You kind of see that I will have 3 cycles of sine. Okay, I have 3 cycles of sine. So 1, 2, 3. Okay, this guy will be pi over 3, this will be 2 pi over 3, this will be pi. Okay. Yeah, then all I need to do afterwards, right? Okay. Let's treat this as constant, this will be 5, and this will be -5. Okay. Then afterwards, c equals to c is -1, right? So once I have this graph already, then all I need to do is to shift it down by 1 unit. Okay, so sorry, this is 2 pi over 3. Okay, sorry, I made a mistake. 2 pi over 3, so you should have 1.5. Okay. My bad. So afterwards, it should look like this. Okay, it will look like this. Okay, I forgot to speak up. Okay, yeah. So your graph shows up like this. Then afterwards, all you need to do is to shift it down by 1. Okay, so your final answer should look like this. Okay, so pi over 3 should complete 2 pi over 3 should complete one full cycle. Then the remaining one will complete the last. Okay, and the new maximum will be 4 and the new minimum will be -6. Okay, any questions for this? Okay, this one is fairly simple. Okay, as I said, the more troublesome one is when you also combine it with the reflection. Okay, then in this case, if I want to do like -5 sine 3x -1, then it will look like this. Okay. And this I already can't mention, but since we're talking about cycles, then like one cycle of a sine is the red color, one cycle of cosine will be blue, and one cycle of tangent will be this. Okay. Then now we move on to this concept called the principal value. Okay, so principal value. Well, I'm sure you've seen triple functions and this thing called inverse. Right? So this inverse functions actually give you some angles. Okay. So the graph looks like this. Okay, so what the inverse triple function does, right, is you give it a number, it will spit out an angle. Okay. So for example, if you use a sine inverse function, I put in sine inverse -1, it will actually give you -90. Okay. So if you put in a number, it will give you an angle. Okay. So if you look at a typical like sine graph, right? Okay. So what this inverse triple function actually does, okay, suppose I have a point here, okay, half, okay, this point here gives me half, okay, rather here, okay, we know that sine of 30 degrees is half, okay, so this is, sorry, this will be half, this will be 30 degrees, okay, 30 degrees, okay, so we know that sine of 30 degrees gives me half. So this means if we use a calculator, we calculate sine inverse, right? Actually, the answer will split out half. Okay. But then, what I say is, okay, this is 30, this is half, right? But doesn't every point here give me half? So like this point here will be 150 degrees. Okay. Then blah blah blah. All of these points here. This point here will give me half. Will give me half. This point here will give me half. This will give me half. This will give me half. So actually, there are like infinitely many values that will give me half, right? So that's a pretty annoying thing. See, these values, all these y values here will give me half also. Which is troublesome. So what the inverse function does, right, is it will pick only one of these values. It won't tell you, okay, there's like infinitely many values that give you half. It will pick one value, okay, and the value it picks is within a range, okay, it's within a range. So this range is called the principal value, okay. For sine inverse, right, the angle will be between minus 90 to 90. For cosine inverse, it will be from 0 to pi, and for tangent inverse, it will be from minus pi over 2 to pi over 2. Okay. So okay, let's see an example of what I mean. So for sine inverse is from minus 90 to 90, right? Okay. Minus 90 to 90. Okay. So let's say I'm asked to calculate what is sine inverse of half, right? Then half, as I said, right, there are so many points that give you half. Okay. So here is 30 degrees gives me half. Okay, all of these are half. Then this angle here is, I think, minus 120 gives me half. Then this guy is uh 150. No, this is minus 210. Okay, so you see a lot of places actually give me half. Okay, but then the principal range, right, as I said, is going to be 90 degrees to 90 degrees, minus 90 to 90, right? Okay, so if I look at this minus 90 to 90, okay, minus 90 to 90, then which answer satisfies? Okay, you have minus 210, which is obviously minus 210 is not inside. 150 also is not inside. So the answer actually, we want to choose this guy only. We choose this guy only. So the answer for this is actually just going to be 30 degrees. Right, let's see how this works. So you want to only pick one guy, right, that's within the range. So that's the idea behind the principal or the inverse trigo function. Okay. I still think it's a syllabus, but it's just quite rarely tested. Yeah. That's why you might need some time to take it and understand how it works. Because okay, definitely AMath, like you will use sometimes you will use this inverse trigo function from AMath, right? Yeah. This one is a bit in greater detail. Okay. Yeah, okay, for this portion, I think if you say you never learned before, I think if I introduce from scratch, it'll take too long also. So yeah, this one, okay, I'll just say, right, it's very rarely tested also. So honestly, it's something that I don't think I have time to go through here, but you can give this a read also. I believe in the whole TYS, I don't think I saw a single question that has something to do with this. Okay, but it's more of the type of question where like some schools, the prelim paper, maybe like 1-2 marks, they'll test this stuff. Okay. Yeah, so this part I think I won't really go through. You can give this a read, then if any questions, then you can let me know. Okay. If you want to skip it also, I think most schools will test the R formula, trigo equation, trigo identity anyway. You want to really test this stuff. Okay. Then we jump into trigo identities. Okay. This one is like the number one most tested stuff. Okay, for trigo. Okay. Identity. Okay, for algebra, and an example of an identity in algebra is like a squared minus b squared equals to a plus b times a minus b. Okay. And for trigo, you have a lot of identities. I think you already count those, right? Okay. Okay, the derivation I will skip also. You can look at it if you want, but not too necessary. Okay. But the three important guys you need to know: sine squared theta plus cosine squared theta equals to 1, 1 plus tangent squared theta equals secant squared, and 1 plus cotangent squared equals to cosecant squared. Okay. So these three guys are in the formula sheet, the first page of your exam paper. Okay. How to go from one to the other? Okay. So actually, the only one you really need to memorize, if you even want to, is this. This is the only one you can memorize. Okay. The other two, right, you can actually get it from this guy. Okay. So the first one you actually divide by sine squared theta. Okay, on both sides, and then to the second one is divided by cosine squared theta. Okay. But of course, that's if you want to like know how to derive it, and you just refer to the front page if you need to use it. Okay. So this is pretty useful. Okay, it allows us to prove some identities. Okay, that's one thing we'll see in a bit. Okay, the other thing is it can help us solve some questions on this. So earlier, right, this kind of question we need to draw the right angle triangle. Oh, okay, this one cannot. This third quadrant. So we use the reference angle. We use, or you just go and calculate directly, right? Okay. Now we have a new method. We have the value of cosine and we want to find sine. Right? Okay, just use this formula over here, the first one. Okay. But remember when you take square root, must put plus minus. Okay. But then in the end, right, sine theta is in the third quadrant, right? So AST. So third quadrant means sine is negative. Okay, so you reject the positive answer. Okay. So this is an example used of the so-called Pythagorean identity. Okay. Of course you don't need to care about name, but yeah, it is related to the Pythagoras theorem. That's why it's called that. Okay. So proving identities, okay, this one is, okay, I'm sure you have had a fair share of trouble with this. Okay? It's quite troublesome usually. Okay, so there are a lot of methods. Okay, I cannot list every single method there is, but the only advice I can give, right, is if you practice more, you will know more techniques. Okay, some of the strategies include combining fractions, then you simplify. Okay, this one of the most common one. Second one is to use identities in the formula sheet. Okay, so the identities to use, right? Usually there's a square, if there's a square term or something, then you will use the identities. Okay. That's an idea. Okay. Then part three, expressing all terms into one or two trivial terms. Okay. So let's say you have sine, cosine together, right? That's not very good. So you want to convert maybe all the cosine to sine, all the sine to cosine. Okay. Part four, looking to cancel terms. Okay, this one quite common also. Try and use some kind of simplification to cancel stuff. And lastly, okay, this one is the most difficult one, is when you have to multiply top and bottom by a certain function. Okay, I think I have an example that will cover that. Okay, yeah, but for the last one is really if the question requires that, then it's very difficult. Okay, and also trigo identities, there's a left side, there's a right side, right? So usually left to right is easier, but sometimes in the rare case you go from right to left. Okay, both are doable. One side usually is harder than the other. Okay, so let's see some examples here. So the first one, cosine theta, cosecant theta, tangent theta equals to 1. Okay. So when you see some stuff like this, right? When you see tangent with sine or cosine, what you should do is to write tangent in terms of sine and cosine. Okay. And all this cosecant, all that stuff, right? Any kind of the reciprocal function, right? Which means cosecant, cotangent, or secant, right? If you see any of these guys, you should try and write it in terms of sine or cosine. Okay. Tangent also if necessary. Okay. So once you do that already, then actually this one becomes very easy, right? You will just cancel everything and become one. Okay, this one easy. Okay, what about part B? Okay, part B, cosine, cotangent plus sine theta equals to cosecant theta. So this one, hopefully you all can see that because the left side there is cosine and cotangent together, you should write the cotangent as cosine over sine. Okay, cotangent is 1 over tangent, it just means it's cosine over sine. Okay. So we start with the left side again. Then cotangent, cosine theta, cotangent theta is cosine times cosine over sine. Okay. Then here, okay, notice the right side, right? The right side here, there is only one term. Only one term, right? So the left side, you should make there be only one term only, also. Okay, to try and simplify. Okay, then once you do that already, okay, once you combine this sine theta with this fraction here, you will see that actually it's very nice, right? Because cosine square theta plus sine square theta is 1. Okay, from this formula over here, is equal to 1. Then you are done already. 1 over sine theta, then cosecant theta. Done. Okay. Okay, so this brings me to the point, right? If you see any kind of square trigo functions got square inside, and you don't know what to do afterwards, you look at the formula sheet. Usually there's some formula to simplify. Okay, so the last one, okay, of course, the last one is foolish to go from, if you want to go from here to here. Okay, so you go from left to right. Okay, so this one you can, one of the methods you can do also is combine the fraction together, then you try and simplify afterwards. Okay, so you combine the fractions. Okay, seems quite bad, but then actually it becomes this. Then actually secant square theta, right? You can use one of the formulas in the front page. Okay. Or here they use tangent square theta. Okay. They use tangent square theta. Then actually secant square theta minus secant square theta. Okay, then actually everything will cancel out very nicely. This 1 plus secant theta cancel with this. There's 1 over tangent theta, which is cotangent. Okay, so these are just some examples of questions that do appear. Okay, these are I think maybe moderate difficulty. The first one is quite easy. Part B and C is like middle like maybe like a 6 out of 10 difficulty. Okay, any questions for this? Okay, okay, this one I think some of them are a bit hard. Let me see. Maybe we don't have time to do it all of them. Okay, I think A and C. Give you all maybe about 4 minutes. Okay, now my C actually not easy. Okay, just do A again. Do A again. Wait, Jonah down with A or Atlanta A. Okay. So of these 3 questions, okay, actually B and C are pretty difficult. Hopefully you all can give this a try at home. Okay, C is actually really difficult. If you can do C means you can do all these questions already. Okay. A is maybe like a 7. B is maybe like an 8. I honestly C is probably like a 10 already in terms of like difficulty for O level standard. You know, this math, AMath standard in general. Okay. Okay. So this guy, okay. Here we want to go from left to right. Okay. Okay, then as mentioned, right, if you see sine or cosine and you see tangent, secant, all this stuff, right, you should try and write it in terms of sine and cosine. Okay, so secant is 1 over cosine. Cotangent is cosine over sine. So here there's a fraction, then we should try and combine the fraction, see if it simplifies anything. So it's sine x, 1 over the denominator will be sine x plus cosine square x over sine x cosine x. Okay. So this doesn't really help much. It doesn't really help much for now. Okay. Let me see. Okay. Then I think I need to multiply sine x. Let me see. Okay, I think here you shouldn't. Okay, actually, the sine x, these two guys will cancel. This sine and sine will cancel. So it'll be sine x plus cosine square x over cosine x. Then now I think you see the right side, right? The right side there are two terms. Okay, here you can also make that be two terms by splitting them up. So sine x over cosine x plus cosine square x over cosine x. Okay, so here the left side, this guy becomes tangent, and cosine square x over cosine x, one of the cosine x cancels, right? So it'll be cosine x. Okay, this one is more like a 6 out of 10. 5 or 6 out of 10. Okay, I thought it would be a bit harder. Equals to right hand side. Okay, then you're done. Okay. I'll show you all the working for part B. Okay. Yeah, part C then you can go give it a try. Okay, as I said, you can solve it, right? All these questions will be easy. So part B, okay, part B you want to start from the left hand side. Okay. And then part B, the key step is to realize that this guy cosecant square can be written in terms of cotangent square. Okay. That's one of the tips I gave earlier, right? The tips I said, if you can write all your terms in terms of one trigo function. So in this case, we're going to use cotangent. Okay. So cosecant square, we can write it as cotangent square plus 1. Okay, cosecant square equals cotangent square plus 1. Look at the formula sheet. Okay. So this is our original equation, and we can convert to cotangent square plus 1. Okay, then the next step is to realize that this actually you can copy the square, right? It's just going to be cotangent x plus 1 whole thing square. Okay, then the next step is to see the cotangent, right? Write it as cosine over sine. Okay, and then afterwards, right, is to remove the fractions. Okay, so to remove the fraction, you multiply the top and the bottom by sine square x. Okay, that's why I say it's not easy to see. Okay, so you multiply the top and bottom by sine square x, then actually this guy will cancel, this one will cancel. Then you're left with 1 over sine square x, which is cosecant square x, which is the right hand side. Okay. So of course there are a lot of moving parts in this question. That's why I say this is one of the harder topics. Okay. You really need to practice a lot of solving identities to do well in to do well in levels, O levels. Okay. It's quite okay. You see the questions right in the TYS. It's actually much easier than this one. This one is like very difficult really by the standard. Okay. Yeah, but do give it more practice. This one is one thing I'll focus on. Okay, this one and the trigo equations. Okay, so now we move on to trigo equations. So trigo equation basically we want to solve some trigo function equals to some value, right? That's what we want to solve. Okay. So there are, of course there are if you don't limit your graph to an interval, you don't say okay I want 0 to 2 pi. There are going to be infinitely many solutions. Like your graph repeats forever. So there will be a lot of solutions. Okay. So for this interval from minus 3 pi over 2 to 7 pi over 2, there are already 5 solutions. Okay. Okay, then I think solving a trigo equation you all should be quite familiar with it. Let's go through the steps briefly. Okay. Write the equation in the form where your trigo function equals to some constant. Okay. So something like 5 tangent x equal to 3, right? It's not good yet. Okay. You want only the trigo function by itself. Okay. But if it's like tangent, if it's like I don't know, sine x equals to half, like that, then it's good. Okay. Make it so that the trigo function on the left side only and the right side is some number. Okay. Then next one is to find a reference angle. Reference angle, how you do that is you go and apply the inverse trigo function. Okay. So in this case, sine is equal to half, right? You find sine inverse half. Okay, even if it's minus half, reference angle, remember reference angle you don't care about the sign. Okay, so for sine is equal to minus half, the reference angle will be sine inverse of half. Okay, then afterwards you determine what angle it lies in. First, second, third, fourth, okay, AFDC. And then you solve for a set of x values. Okay, you solve, okay, if it's in quadrant 1, then it's just going to be a reference angle. Quadrant 3 then is 180 degree, no. The angle minus 180 degrees, okay, no. Sorry, it's 180 degrees plus the reference angle, okay, then etc. etc. Okay, then lastly, right, okay, this one is like a trick, okay. If your interval is big enough, okay, so your interval, let's say, usually what you do, right, you solve for 0 degrees to 360 degrees, right? Okay, if it's big enough, they'll say like this, for example. Then if your answer is within the radius, the range, right, you can plus 360 degrees again. Because it's the same angle, you just add one more revolution. Okay. And any questions about the steps? Okay. So the steps I'll go through very quickly. This one give more time to practice. I think you should be quite familiar with it. Okay. So sin x equals to ln 2. Okay. Ln 2 is positive. Okay. So reference angle is sine inverse of ln 2. It is 43.880 degrees. Okay. Then ln 2 is positive. So AS means it lies in the first or second quadrant. Okay. First quadrant is just going to be alpha, and second quadrant is 180 degrees minus alpha. Okay, then there's two answers. Okay. Then part B. Okay, part B, sine 20 degrees is positive. So tangent inverse of it is 18.882 degrees. And tangent positive means AST. So must lie on the first and third quadrant. So first quadrant is alpha and third quadrant is 180 plus alpha. Okay. Then okay, for part C, right? Part C need to take note. Okay. They say x is between 0 and 360 degrees. So that means 3x, right, is between 0 and 1080 degrees. Okay. Need to take note of this. Okay, in case you have some solution you can get by adding 360 degrees. Okay. So now, okay, this guy, right, is negative. Okay, take note, it's negative. Okay, but then the reference angle will be cosine inverse of 0.4, not minus 0.4. Cosine inverse of 0.4 is 66.4422 degrees. Okay, then cosine is negative, so ASTC. Okay, so cosine, this angle must lie in the second or third quadrant. Okay, so second quadrant is going to be 180 minus theta and minus alpha, and third quadrant is 180 plus alpha. Okay, but then notice, right, actually my answer, okay, my range, right, as I mentioned, it must be between 0 and 1080 degrees. Okay, 0 and 1080. So 0 and 1080 means these values, right, are quite small, right? So I can actually rotate one more time. I add 360 degrees to this guy, I add 360 degrees. This guy, I add 360 degrees. Then I will try adding one more 360 degrees, 720, and this one 720 also. Turns out all is allowed. Okay, all of these are allowed. Okay, then this is 3x, right? So x is just all these values divided by 3. Okay. Then lastly, okay, some more examples, right? Some more examples, go and try questions. Okay. Tangent square x equals to half. Okay. So here we need to square root both sides, right? Okay. But remember to put plus minus square root. So it'll be plus minus 1 over square root 2. Okay, but then plus minus 1 over square root 2 means it's both positive and negative. If it's positive and negative means it lies in all four quadrants. Okay, then you have to consider four values. Okay, then for part B, tangent x equals to 0. Okay, this one you can solve it using the usual way. Okay. Or you can just, if it's some special value like 0, you can just draw the graph and then just find the answer. So it just be 0, pi, and 2 pi. Then for part C, okay, part C is also an easy question, but just notice that it's not in the form where your trigo function is some constant equal to some constant. Okay, here you need to divide by 2, so it's sine x equal to half. You're solving from minus 2 pi to pi. Okay. So reference angle is pi over 6, and then positive first and second quadrant, then you get two values. Okay. But then notice that you have minus pi in the interval, so you can try rotating clockwise. Okay. go clockwise one time. You'll see that there are two more answers that you need to accept. Okay, any questions? Okay. For this one, A and B, maybe about 5 minutes. A and B. Okay, for coordinate geometry, there is some part as the AMath portion. The AMath portion of coordinate geometry, I think I'll just have to save it. Okay, Janelle done. Okay. For A and B, I don't think I'm too difficult, just some practice, right? Okay, but like in general, you can expect in like the harder papers that you practice, right? What happens is usually they'll give you like a trigo identity. Okay, then you have to prove it. Then after they ask you to use that in the subsequent trigo equation. Okay. Okay, so the first one I think is quite simple. Okay, just notice that okay, sine x cosine x. Okay, okay, actually maybe it's not as simple. Okay, but like if you know the pattern, actually what you do is to divide both sides by cosine x. Okay, so sine x divided by cosine x equals to cosine x over cosine x. Okay, which actually just means you're solving tangent x equals to 1. Okay, then tangent x equals to 1, tangent is the basic angle or the reference angle is tangent inverse 1 pi over 4. Then tangent positive means it must lie on AST, so first and third quadrant. Okay, so it's going to be pi over 4 and pi plus pi over 4. Okay, once you see it, then it's easy already. And then for part B, okay, part B might seem a bit strange, but actually what you can do is to factorize this equation. It's a quadratic equation in terms of sign. Okay. If you factorize it, you get actually 2 sine x plus 1 times 2 sine plus sine x minus 1 equals to 0. So sine x is equals to negative half or sine x equals to 1. Okay. So you basically have to solve two equations. Okay. So for the first equation, okay, the reference angle is pi over 6. And then for this one, then it's negative. So it must lie on the third or fourth quadrant. So you have two answers here. Okay. Then the second equation is sine x equals to 1. Okay. Then for sine x equals to 1, you can just get a graph. So sine x equals to 1, you draw from 0 to pi, right? Where does sine x equals to 1 is equals to pi over 2, right? Okay. So essentially you have two answers here, you just add pi over 2. Okay, any questions? Okay, we have a quick 3 minutes break, then we'll continue. Okay. Okay. Addition formula and double angle. I think we won't really have too much time, but I think you have any issues with knowing how to use those. Okay, I think addition formula. Okay, addition formula is very obvious how to use it. Double angle, then yeah, you really want to use it when you have an equation that has 2a and a inside, for example. Okay, or you can use it to simplify things also. So of course, these two you can. It's also usable in questions that involve identities for equations as well. Okay, and yeah, trigo equations and identities, like, it's one of the. I would probably say it's the hardest thing in AMath. Okay, I would say because if it's a hard question, it can be really hard. Yeah, sure. Yeah. Okay, let's continue. Let's finish up with Trigo. Okay. So there are only two portions left: double angle and addition formulas, and then R formula. Okay. I think addition and double angle, as I mentioned, I don't really think is too troublesome. Okay. Yeah, once you do enough questions, you will know when to use them. It should be quite obvious. Okay. Addition formula is very easy to see when to use it. Double angle is might not be so easy to know when to use it, but yeah, it's when you're dealing with questions that have like 2x and then x also at the same time, then probably think to use it. Okay. So the double angle form all of these formulas are really just given in the front page when you memorize anything. Okay. So like quick example, if they say using cosine addition formula, then of course use cosine addition formula, right? Okay. Then part B, if they ask you to find the value of sine of A minus B, then you just do it accordingly. Okay. The techniques to find these things, right? The techniques to find these things we've already covered in the previous all the previous content. Okay. Then for part C, okay, solving an equation. So basically for this one, you just have to simplify using the addition formula. Okay. The step you can take a look at it, right? Nothing too crazy. Okay, for the first one, you just expanding it, use the special formula, special angles. Okay, for part B, essentially doing the reference angle stuff, just that with A and B. Okay, and then you combine them together in the expansion in the addition formula. Then for part C, you are just going to be expanding it and then simplifying. Okay. So really all the same concepts do apply. Okay. Yeah, there's some more these questions that I'll just quickly show. Okay. Sine 2a. Okay, sine 2a is actually 2 sine a times cosine a. So this one we already know how to find cosine a if we have sine a here. This one for in this case, right, because a is between 0 and pi over 2, you can go and draw a right angle triangle. Okay, that one works, but you can just use one of the usual methods. Okay. Then cosine 2a is 1 minus 2 sine squared a. Okay. You can calculate that easily. Then tangent 2a is 2 tangent a over 1 minus tangent square a. You can calculate tangent a using the right angle triangle. Okay, then for part B, prove an identity that has a double angle term inside. Okay. So this one I start on the left hand side. Okay, then you expand it. Okay, then notice that 2 sine x cosine x is actually sine of 2x. Okay, then the cosine square plus sine square x equals to 1. Okay, then done. Then for the last one, okay, this one is a bit trickier, okay, but essentially, okay, the idea still applies, right? Here you have sine and you have cosine, which is not ideal, right? You want everything in terms of sine or everything in terms of cosine. Okay. So in this case, you probably want to make everything in terms of sine because you cannot really change this in terms of cosine. Okay. But this guy you can change in terms of sine only by using this. Okay. So once you do that already, then it is I think it's just a quadratic equation. Okay. Okay. Once you express that in terms of sine only, then it becomes a quadratic equation and you can solve it. Okay. Yeah. Okay, then lastly we talk about R formula. Okay, R formula you want to use it when you have an equation like this. A sine theta plus B cosine theta equals to K. Okay. The issue is okay, when K equals to 0, then we can actually just move the cosine over, then we divide cosine on both sides to get tangent. Okay, which you can solve easily. But then if you do not allow K to be 0, okay, then you just think of R formula. Okay. Yeah, so the derivation of this I'll skip it. But essentially what we do want is this. Okay, these two formulas, this is the important one. Okay. So if the sign is in front, then if the sign is the first term, right, A sin theta plus minus B cosine theta, then the R the trigo function with R will be sine. Okay, if cosine is in front, the trigo formula with R will be cosine. Okay, and right, you see the minus plus, you see this upside down. Okay, this thing means if this is a plus, this guy will be a minus. Right, you don't know how you see that, right? Okay. Yeah, and then R equals to square root A squared plus B squared, and tangent alpha is B over A. So alpha is tangent inverse of B over A. Okay, and once again, right, B over A, don't go and put the signs. Okay? You just you take the number itself, don't care about the minus or whatever. Okay. So we can see this in use here. Okay. For the first one, A is 2 and B is root 3. Okay. So here the sign is in front, right? The sign is in front. Sign is in front. So we want to use a sign here. Then the plus here will be the same as this. So R will be square root of 2 squared plus square root 3 squared, which is square root of 7. And alpha is tangent inverse of square root 3 over 2, which is 40.9 degrees. Okay. Then it will just be R sine of theta plus alpha. Okay. Then the next guy, now the cosine, right, is in front. So that means here should be a plus, and then this term should be a cosine. Okay, the R will be equal to 5, and the alpha will be tangent inverse 4 over 3. Okay, notice that it's not tangent inverse of minus 4 over 3, it's tangent inverse 4 over 3. Don't care about signs. So 0.927 in radians. Okay, then it will equal to R cosine of theta plus alpha. Okay, so I think, let's see here. Okay, I think we only have time. Okay, let's just solve this first question. This one. Yeah. The other question can give it a try also. As per usual, I'll send the slides or notes into the chat afterwards. This one should take about 3 minutes or so. Alright, good. You're done? Alright. So this one, alright, using our formula, okay, the number in front of cosine is just going to be 1, right? So this one we want to express it. Okay, this one I suggest to always write it in. I suggest to always write it. Then you want to express it in a certain form. Okay, so this one I want to express it as r cosine. Okay, this will be theta plus alpha plus. Okay, this because this is minus, so this will be a plus. Okay, so I want to convert this guy into the r formula form first. Okay, the two I just don't care about it first. Okay. So the r here will be square root of 1 squared plus square root 3 squared, which is square root of 1 plus 3, which is square root of 4, which is 2. Okay, and tangent inverse of b over a is tangent inverse of square root 3 over 1, which is going to be 60 degrees. Okay, so that means we want to solve 2 cosine 60 theta plus 60 degrees equals to 2. Okay, which means that cosine theta plus 60 degrees equals to 1. Okay, then we can just cosine inverse of both sides to get the reference angle. Okay, actually in this case you don't need to because it's a very nice value. So if you were to draw your graph, right, your graph looks like this, right? So when it's equal to 1, where is the value of theta when cosine equals to 1? It's at 0 and at 2 pi. Correct. Well, this is 360 degrees, so 360. Okay. So you have two angles, 0 degrees and 360 degrees. Okay. But this is theta plus 60 degrees, so you must minus 60 degrees on both. So minus 60 and 300. Okay. And we have to solve from 0 to 360, so you should reject the minus 60 degrees. Okay. And lastly, okay, for this part, okay, this one I won't really have time to go through, but our formula usually accompanies geometry questions like this. Okay. They give you like some picture of like some situation, usually some kind of track or whatever, right? Okay, they are to express in terms of our formula. Okay. This one we won't have time to go through, but like generally in the exams, right, it will be like this kind of parts. Okay. Part A is to show that some parameter or whatever, in this case parameter will be can be expressible in terms of some R formula form, and then after you solve the trigo the R formula trigo equation. Okay, this one you can refer to it or give I'll suggest trying it out after you refer to it after you're done. Okay. And lastly, okay, trigo equations can also trigo questions can involve real life situations. For example, like temperature. Okay. Yeah, this one I would say is a bit less common. Okay, nowadays. Okay, actually a bit more common nowadays compared to a few years ago, but still not so rare. Still not super common. Okay. So they use trigo functions to model real life situations. Okay. If you are given this kind of questions, it will usually be quite guided. So don't worry too much about it. Okay. This one I also won't really have time to go through this. Okay. Yeah, we will spend the rest of the time on coordinate geometry. Okay. Yeah, so Trigo really there is like so much stuff. I think like your schools would have spent like maybe like a few months covering this. Okay. So of course this 3 hour session, like now I think we spend about 2 hours 20 on this is confirm a bit rush, right? Hopefully it will help you like hopefully you've learned something or you would have jogged up a memory on certain things. Okay? And you know maybe what you don't know. And that's the most important thing. You don't go the worst thing is if you don't know what you don't know. Right, then you don't know how to practice on. Okay. Then here maybe you do some practice. Okay, I'm bad at trigo equations, then you practice more. Trigo analytics. Okay. Okay. Then the quick overview on this. Okay, a lot of stuff. Okay. We're done to read through all this. Okay. I suppose this will be pretty useful when like if you are practicing, then you can just like pull this up and take a look at for quick reference on what you might want to look at. Okay, yeah, and as per usual, yeah, any questions once you review the stuff, then you can let me know as well. Okay. Okay, now coordinate geometry. Okay, so this chapter, okay, of course we don't have it's still pretty long, but we won't have like that much time on it. Okay. But the good thing is, okay, you might see it's like 56 pages, okay, but I realized the bad part of the chapter has the linear law, which is you're not tested on that, right? The last part of that. So and I went through that generally. So yeah, the very last portion of this chapter is actually not included. So yeah, we will spend time talking about the AMath portion, okay, which is going to be essentially it's going to be a perpendicular bisector, a perpendicular line, okay, and the area of the shoelace method, the area of like, the polygon and stuff, okay, quadrilateral, okay. So our first objective, okay, conditions for two lines to be parallel or perpendicular, then midpoints of a line segment, okay, and what even is a line segment, then area of 2D figures, okay, any amount of vertices, okay, so vertices are the different points on the shape, okay. And then lastly, we talk about coordinate geometry of circles in general or standard form. Okay, the transformation one we already covered. Okay, So this is really the AMath portion, the AMath portion. So I don't think you all will be too foreign with this, hopefully, right? Okay, any angle inclination. Okay, maybe this is not really that, but like, okay, angle inclination is basically the angle line mixed with the positive x-axis measured and clockwise. So actually, this kind of looks like the angle in trigo, right? Looks like the same way you measure it. Okay, so the angle of inclination can be acute or obtuse. Okay, doesn't really matter which one it is. Okay, then now we introduce the gradient of a line. Okay, this is like a rigorous way to define the gradient of a line. Okay, you all would more or less have an idea of how to calculate the gradient of a line really from AMath. Gradient of a line is the rise divided by run. Okay, or in other words, it's the measure of how steep a line is. Okay, so if your gradient is higher, the line is steeper. Okay, if it's positive means your x as your x increases, the y increases a lot. Okay, if your gradient is large and negative means as your x increases, your y decreases a lot. Okay. So what this gradient here, okay, how is it related to this angle of inclination? Actually, it's related to the angle of inclination by gradient we usually use the alphabet m to denote. So m equals to tangent theta. Okay, where tangent is a trig function, the one we just used, right? So why is that so? Okay, so tangent. Okay, so this is a right angle triangle, right? Okay, so by and I think corresponding angles. Okay, by corresponding angles, this angle here and this angle here are the same. Okay, they're the same angle. So this means that right, if you consider this triangle here, we consider the inner triangle. This means that tangent theta is opposite of adjacent. Right? So opposite is y2 minus y1 and adjacent is x2 minus x1. And that's exactly the formula for my gradient, right? M equals to y2 minus y1 x2 minus x1. Okay. So M equals to tangent of theta, where theta is the angle of inclination. Okay. Yeah. Then now, okay, we can start looking at a parallel line, a pair of parallel lines. Okay, so parallel lines, okay, how are they related to each other? So let's look at these two. Okay, should be quite obvious to tell that the angle of inclination for both of them are the same, right? Okay, they're the same. So if the angle of inclination is the same, it would also mean that the gradients are the same. Okay, so this means m1 equals to m2. Okay, so if m1 equals to m2, the gradients are the same, that means the angle of inclination are the same, which means they are parallel. Okay, they're very easy to see. Okay, then the C, these two C's here, right, C1, C2, it just tells you whether you move it up or you move it down. Okay, that's for quick visualization. Okay, so if the C increases, then if the C increases, then it goes up. And if C decreases, it goes down. See that? Yeah. The gradient is the one, the control of the slope will remain the same. Okay, if they are parallel. Okay, determine whether the lines A, B, and C they are parallel. So give reasons to support your answer. So to do this very simple, right? You calculate the gradient of line AB and line CD. Okay. If gradient of line AB equals to gradient of line CD, then they are parallel. Okay. So in this case, AB is 1, gradient of line AB is 1, and gradient of line CD is -1. So they are not parallel. Okay. In fact, you'll see that they are perpendicular later on. Perpendicular condition is that the product of their gradients is -1. So 1 plus -1 is -1. Okay. Then for part B, okay, for part B, -2 and -2. Okay, so that's good. Then they are parallel. Okay. Suppose. Okay, I suppose we give this question a try. Okay, I don't believe you all would have heard of this point called collinear before. Heard before. Okay, but anyway, it's given here. So collinear points means let's say I say A, B, and C are collinear. It means that they lie on the same straight line. Okay. So once again, give this question a try. Okay, about 2 minutes left. Yeah, we have five, so like you know how to log out of this. Okay, you can for this thing and then like later log out. Okay, Jonah done. Okay, so this question actually like okay the words they use like strip and polynomial, but it's actually what I mean. What you the base idea is to do is the same as previously there, which is actually just to prove that the gradients are the same. So actually you can kind of think of it this way. You can do a simple drawing, right? Okay. Like A, B, C, right? So 3 points, they like just PQ or whatever, right? So if they lie on the same straight line, what does it mean? It means that A, B, right? This gradient, say M1, and the gradient of B, C, M2, they must be equal, right? Right, makes sense? Okay, besides that, right, another thing that you must choose also is that B, like you must choose a common, so-called common point. So you calculate the gradient of AB and BC, okay, then they are equal and it's good. Okay. But if let's say I were to, okay, so here is actually, if you do it with 3 points, it will always be the case. But what if I have AB and maybe like CD? Okay, maybe like here, CD. Okay, so if I have somehow I have 4 points, right? Then I calculate the gradient of AB is equal to M, like say 5. And I calculate the gradient of CD is equal to 5. Okay. So in this case, they are parallel, but they're not collinear. Okay. They're not collinear because I mean this guy is clearly they don't touch, right? They don't touch at the same point. So to prove that they are collinear, you need to calculate when you calculate the gradient of each of these things, they need to have a common point. Okay, so in this case, AB. Okay, any of these will A B A C A B B C also works. Okay, A B A C is A as a common point, and A B B C is B as a common point. Okay. Yeah. So in this case, okay, I calculate P Q and Q R both are 1. Then I choose Q as a common point. Okay. Q both has. Okay. Any questions? Okay. Okay. Now is the AMath portion already. Okay. Perpendicular lines. Okay. So it's not very obvious to tell. Okay, like parallel lines is so easy to tell. Just look at the number in front of x, the gradient. Okay, but perpendicular is a bit harder to tell. Okay, if I give you 2 lines of perpendicular, okay, if like you never learned it before, then you won't know how to do it. But then now, okay, you know that the product of the gradients is going to be -1. Okay, yeah, the proof also is not easy, so let's skip it and just say that okay, 2 lines are perpendicular if and only if the product of the gradients is -1. Okay, so in this example here, y equals to -1/5x and +3, and then y equals to 5 minus 2. So these are perpendicular because -1/5 times 5 is -1. Okay, so this is a quick sketch of what it looks like. Okay, and notice, yeah, the y-intercept doesn't really the y-intercept doesn't really determine anything. The only thing that determines whether the lines are perpendicular or parallel would be the gradient. Okay. So an example, this one is a typical, I think this one is a O-level question, typical O-level question. Okay. Okay, so a very common thing that the exam papers will do is to not give you in the form y equals mx plus c. Okay, if it's in the form y equals mx plus c, then the gradient is very easy to tell. Okay, But they'll give you things like 3x plus y minus 1 equals 0, which is not in the required form. So what must you do? You must write it in y equals mx plus c first. So in this case, it's y equals to minus 3x plus 1. Okay. Then they say find the equation of the line passing through this, which is perpendicular to the line 3x plus y minus 1 equals 0. So this means it passes through a point and it's perpendicular to this line, right? So that means this info here will tell us the gradient, and this info here tells us a point. So you can use a y minus y1 equals to m times x minus x1. Okay. So if minus 3x, if the gradient of this line is minus 3, that means the gradient of the line that's perpendicular to it is minus 1 divided by minus 3, which is 1 over 3. Okay, then since it passes through A, you can use the y minus y1 equals to m x minus x1. Okay, and this is the final answer. Okay, so you always need gradient and then you need a point. Okay, once you do that, then you're done. Okay. Given that the two lines intersect at point n, find the coordinates of n. Okay, so here you have equation of the perpendicular line and then the equation of the line itself. You can go and use simultaneous equations to solve for the intersection. Okay, so you let this be equal to this. Okay, then you solve it simultaneously. Equation 1 equals to equation 2, and then the answer is x equals to minus 11 over 10. Sub back in into the first or second equation, you get y equals to 43 over 10. Okay. So the point of intersection is minus 11 over 10 and 43 over 10. Okay. So okay, like extra info is called the slope of perpendicular. Okay. And hence find the shortest distance from A to the line 3x plus y minus 1 equals to 0. Okay. So here, okay, this one is a bit tough. If you don't have a picture, it's not easy to tell. But it will lie basically along the line. Okay, you can see the shortest distance from A to this line, right? Okay, the red color line basically. You want to find the shortest distance from A to the red color line. So the shortest distance will actually be the path it takes along here, along this region here. Okay, so basically you want to find this length. Okay, using a distance formula. Okay, the distance formula, just a reminder, is going to be square root of x1 minus x2 squared plus y1 minus y2 squared. Alright? Then you simplify the 3 root 10 over 10. Okay, distance formula also need to memorize. Okay, that one no choice. Okay, but if you can see, it's basically the Pythagoras theorem for the two y and the x length. Okay, any questions? Okay, another question for you. Okay, this one. This one is pretty long. Maybe about 5 minutes or so. Yeah, almost done. Almost done with this. Alright, okay, now, okay. Okay, let's look at this part A. Okay, so part A, okay, given that AB and DC are, okay, AB is parallel to DC, AB is perpendicular, or AB and DC are perpendicular to BC, A lies on the y-axis, and then B and D are 615 and 2 minus 3 respectively. Sorry. And the equation of DC is given as y minus 2x plus 7 equals 0. Okay. So equation of AB. Okay, so equation of AB, okay, to form the equation of a line, you need the gradient and then you need a point on the line. So you have a point on the line here. So the next thing you need is the gradient. Okay. It's given that DC is parallel to AB. So the gradient of this, if you write it in the y equals mx plus c form, is y equals 2x plus or minus 7, which means that gradient is 2. Okay, so this guy's gradient is also 2 because they are parallel. Okay, then simply you have the point 615 and then you have the gradient 2. Right? Use the y minus y1 equals mx minus x1 method. Okay. Then equation of DC, okay, equation of BC. Okay. So this one also is not difficult. Actually, BC we have a point on the line. Okay. And next we need a gradient, right? Okay. So we know the gradient is perpendicular to these two lines which have gradient 2. Okay. So that means whatever the gradient is, right? So m times 2 equals to minus 1. So m must be minus half. Okay, the gradient of this must be minus half, BC. So once again, gradient is minus half, then the point on the line is 615. Okay. Then lastly, coordinates of A and of C. Okay, coordinates of A is simply the y-intercept of this line here. Okay, let x equal to 0. And then for C, okay, for C, you have to solve simultaneous equations. Okay, you have the equation of this line here, BC, and then you have the equation of line CD. Okay. So for equation of coordinates of A, it will be 0, 3, and then for coordinates of C, you solve the simultaneous equations. For lines BC and CD, you will get 10, 13. Alright, any questions for this? Okay, so the next example, yeah, we don't have enough time, so I'll skip it. Yeah, as per usual, these examples that we haven't done, we should go and attempt them and refer afterwards. Okay, then now we look at midpoint of line segment. Okay, so I think this is the last, no, second last portion. Afterwards, no, third last. Okay, so after this, there's still shoelace method, and then there is the circles. Okay, so midpoint. Okay, this one I think if there's an example, I think we don't have time to go through as well. Okay, so midpoint. Okay, the midpoint makes sense. It's just a line segment that divides the line segment into two equal parts. Okay. And of course, the midpoint of line segment AB, right? So line segment means it's a portion of line, it's not a whole line, a portion of it. Okay, the midpoint of AB is you add the x coordinates together, divide by 2, comma, add the y coordinates together, divide by 2. Okay. So these two, of course, each from one of the endpoints to the midpoint is to the midpoint to the other endpoint is the same length. Okay. Yeah, I don't think we have time to go through. I think we can able to do like one good example at the end. Okay, yeah. But I think midpoint questions are not so difficult. Okay. I do want to mention one thing. Okay. Maybe two things. Okay. So for midpoints, one thing I will mention is that okay, this word called perpendicular bisector. Okay, perpendicular bisector. If you have like 2 points A and B like that. Okay. So perpendicular bisector means is a line, right, that passes through the middle of A and B and is perpendicular to the line AB. So it'll be something like this. Okay, 90 degrees. Okay, so something like this, right? You need two conditions. First, you need to find the midpoint of AB. So okay, first step is to find midpoint of AB. And second, you must find the gradient of AB. Okay. Gradient of AB, then you find the perpendicular line gradient. Right? You find the gradient of AB, and then you find the line of perpendicular, -1 divided by that. Okay, then afterwards you construct, finally you construct your perpendicular bisector. Okay, so perpendicular bisector you need two things, you need a midpoint, then after you need the gradient of the line, then afterwards you can calculate the gradient of the perpendicular line. Okay, then you use this point to pass through. Okay, so that's the first thing. Second thing that is special about midpoints is the parallelogram. Okay, so for parallelogram, right, okay, the special property is that midpoint of AC, this midpoint here, is the same as the midpoint of BD. Okay, the other word they use is bisect. They bisect each other. Okay. So why is this useful? Is so if we have 3 points, we can find a fourth point. Okay. How do we do that? Okay. If we have like C and A here, right, we can find the middle here. Then we can reverse the midpoint theorem or midpoint formula to find what is P comma Q. Okay. Yeah. So that's a pretty important thing. Okay, then perpendicular bisector is the portion as mentioned just now. So you can draw a quick sketch. Right, perpendicular bisector means you find the midpoint first, then you find the gradient, then you find the perpendicular bisector. You find the perpendicular bisector's gradient, which is -1 divided by the gradient of the normal line. Okay. Yeah, the example is, I don't think it's too difficult, but yeah, we're going to have too much time to go through that. Okay, then now we look at how to calculate the area of a general figure on a graph. Okay, so in general, it's called a polygon. A polygon means n number of sides. Okay, usually you're asked to calculate maybe 4 sides or 5 sides at most. I don't think anything more than that. It's going to be quite troublesome. Okay, so if we want to find abuse some properties, okay, so for example, area of a triangle, you can say half times base times height. For example, area of a trapezium is half a plus b times height. Okay. For certain shapes, it's not so easy. Okay, that's why you need a general way, which is the shoelace method. Okay, so shoelace method, how does it work? Okay, if you have a polygon with vertices x1, y1, x2, y2 until xn, yn, right? What you do, okay, you lay out as the columns of this thing. Okay, so x1, y1, okay, x2, y2, then blah 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 blah. Okay, then once you reach xn, yn, okay, don't stop. Add, add the first guy again. Add the first guy again. Okay. Then afterwards, what you do, you add some of the terms together and you subtract them together like a shoelace. So the ones that should be added together are the blue color ones, the top to bottom. So this one add, this one add, this one add, this one add, this one add. Okay. Then afterwards you subtract this one, subtract this one, subtract this one. Okay. And this will give you the area of the polygon. Okay, make sure to put the half also, the half outside. Okay. And also one more important thing, the vertices should be taken in a clockwise or anti-clockwise direction. So meaning right, if you have like a, I don't know, like a phi shape hexagon down here, okay. You can go from A, E, D, C, D. Okay, that's fine. A, B, C, D, E is fine also, of course. Even D, E, A, B, C. Okay, but don't go like D, B, A, E, C. Like if you do like that, it's confirm wrong already. Okay. So one more thing about this thing here, right? Basically, this is the area of a polygon. Area can only be positive. So this means, right? Okay, if you get a negative, if somehow this thing gives you a negative answer, this absolute value thing basically is converted to positive. So like let's say half of then inside here is like -100, then you convert it to 100. Okay, that's what it does. Yeah, so an example here, okay, you convert this, okay, now we look at this one instead. Okay. The ABC I won't really go through. ABC is just using the normal coordinate geometry stuff to calculate the different points. Okay, you look at part D. Part D is the area of the kite. Okay. So let's see, okay, coordinates of B is going to be 0, 13/2. Coordinates of C is going to be 1, 2, and for D is going to be 13/4, 0. Okay, so here we choose to go clockwise from A. clockwise from A means A, then D, then C, then B. So 3, 3, then 13/4, 0, then 1, 2, then 0, 13/2. Then we return back to 3, 3. This one don't forget, return back to the original point. Okay. Then you add things together. Add this and this. Then you subtract this. Okay. Then you simplify. Okay. Notice how there's a minus sign here. Okay, but then this thing here makes it positive. So it's 65/4. So answer is 65/8. Okay, for this particular question, because it's a kite, right? Kite actually you can do half times base times height. Okay, you will see that you get the same answer also. But then the shoelace method works in general for any kind of polygons, no matter the shape how weird it is. Okay, that's some more questions. Okay, then lastly we move on to circles. Okay, so circles you need two things. You need for line you need a point and then you need a gradient. Okay, for circles we need two things. We need the radius and we need the center. Okay, so there are two ways to express the equation of a circle: the standard form and the general form. Okay, but the general form is way less commonly used, and I don't really like it too much. You can always convert from general form to standard form. Okay, so the standard form is x minus a squared plus 1 minus b squared is r squared, and the center is a comma b, and the radius is r. Okay, so the general form you can of course tell the radius and center also, but I don't think anyone really want to memorize this. So to go from general form to standard form, right, you complete the square for x and y. Okay, I think there's some example later. Yeah, you complete the square for x and y, but x and the x square you combine together, the y and the y square combine together, then you complete the square for each. Then the remaining number, right, the constant, you just move it over to the right side. It will be some number squared. Okay. So an example for A, you can see here. So I'm given these two are in the general form, so I convert to standard form. I complete the square for x squared plus minus 8x, and for y squared plus 4y. Okay, and then once I do that already, right? Okay, I see that this is the x coordinate of the center is -4 and the y coordinate is -2. Sorry, if x coordinate is 4 and the y coordinate is -2, and then once I move all the constants to the right side, it will be 3 squared, which is 9. Okay, 9 which is 3 squared. Okay, similarly for this, okay, complete the square for y. The x in this case you don't need to complete the square. Okay, it'll be y minus 5 squared y minus 5 whole thing squared minus 5 squared. Okay, then you move everything over, you get 16, which is 4 squared. Radius is 4. Okay, so circles, right, there isn't really much to know about it. Okay, the main idea is really just to be able to convert from general form to standard form. Okay, then once you have standard form, how to tell the center. Okay, once we know this already, right, that's actually it for circles. Okay, I guess we'll calculate the radius. So the radius is any point from the center to any point on the circle or the circumference. Okay, then once you know circles already, right, the harder coordinate geometry questions will just combine circles with all the other stuff we learned. Okay. So I'll go through this last example. I think we can end today. Okay. So a circle passes through the points A, 2, 1 and B minus 6, 5. Find the equation of the perpendicular bisector of AB. Okay, so now is a good time to refresh what we went through with perpendicular bisector. So perpendicular bisector means it passes through the midpoint and then it is perpendicular to the line AB, the original line AB. So midpoint of AB, you add you add 2 and minus 6 together, you divide by 2, it's -2. And you add 1 and 5 together, you divide by 2 is 3. Okay, so that's the midpoint of AB. Then next you need the gradient of the perpendicular bisector, which is -1 divided by gradient of AB. So gradient of AB is 1 minus 5 over 2 plus 6, which is minus half. Okay, gradient of AB is minus half. So gradient of perpendicular bisector of AB. Okay, so for AAB, this is half. Then the perpendicular bisector, this guy will be 2. Okay, gradient of the perpendicular bisector will be 2. Okay, then now I have the gradient and I have a point on the perpendicular bisector. I can construct using y minus y1 equals to m times x minus x1. Okay. Then next, the center C of the circle lies on this line. Find the coordinates of C. Okay. So if you were this one I guess is not very standard also, but it is a fact. Okay, you have a point on the line here, on the circle. Okay, let's just let them be A and B. Okay. The perpendicular bisector, right? The special property, okay. This one, of course, you don't need to know it. It is given here. Is the fact that the perpendicular bisector will pass through the center of the circle. Okay. You don't need to know that. Okay, this is given for this question. Perpendicular bisector, if it passes through the center of the circle, and also I tell you that the center of the circle lies on this line. Okay, means you can just use simultaneous equations to solve to go and find out where the intersection is, where the coordinates of the center is. Okay, in this case, if you solve it, it will be minus 1, 5. Okay, so the center is minus 1, 5. Okay, then now last part, find the equation of the circle in general form. Okay, general form. Okay, they are standard form. Okay, but you can write it in standard form first. Then once you expand everything, then it's general form. Okay. So right now we only know the center of the circle, but we don't know the radius. Okay, how to find the radius? Simple, right? 2 points lies on the circle, A and B. So to find the radius, you can find the distance from the center to either A or B, right? Either the distance from A or to B. Okay, so now we choose to calculate the distance from the center of the circle to A. 2, 1 to minus 1, 5. Okay, the answer is 5. Okay, then now I can write the circle's equation in standard form. Okay, the center is minus 1, 5, right? So x plus 1 squared plus y minus 5 squared. The radius is 5, so 5 squared. Okay, and then you expand everything and then you move everything to the left side. And this is finally your standard form. Okay, yeah, I think the last, okay, then there are some examples. Okay, so this part of the chapter, this chapter, there are part of examples. So yeah, do give them a try to like hone your skills. Okay, the linear law, that's not going to cover that. Okay, so yeah, this chapter has quite a lot of stuff, a lot of content as well. But I think it's really much easier to approach than Trigo. So yeah, but still, nevertheless, still do continue practicing this. Okay. Yeah, I'll send this completed version of these notes to the group later. Okay, yeah, any questions about this topic that you practice, please feel free to send it over. All right, then if not, we'll end today. Okay, and I think next week we have our last module. All right. Okay, then if nothing, then bye bye. See you. Bye bye. All right, see you.